All right, so in this video, we're going to look at slope and rate of change. When we talk about the rate of change of what? Well, what we're going to be talking about here are linear functions. So for a linear function, that's going to be a line graph. The rate of change, that would help if I could spell. The rate of change is going to be the change in the dependent variable, and we usually use y for that, divided by the change in the independent variable. I'm really having trouble with the spelling today, I guess, which we usually use as x. Now, I say for a linear function, the reason for that is because every function has a rate of change that is somewhat this relationship, but the more complicated the function you get, the more changes we have to apply to that statement. So you will hear the words rate of change a lot, however, as you go through high school math, because once you hit calculus in your senior year in college, you will just be talking about rate of change because you will just be talking about functions in general. Could be lines, could be parabolas, could be just about anything. Okay, so with that, we are going to use that term because it's a term that you need to become familiar with. However, when we have slope, that is the rate of change for a linear function. So rate of change, our definition there tells you how to find it, and slope is just a specific term we use for the rate of change. Okay, so what does that look like in terms of math? Rate of change equals change in y divided by the change in x. Okay, so for a linear function, we have four possibilities: positive, negative, 0, and undefined. So again, think about change. So positive slope means it goes up from left to right. We read a graph the same way we read a book. So if it's going up, the y is getting greater. It's a positive slope. If it's going down, the y is getting less. It's a negative slope, right? Makes sense. Positive up, negative down. Slope of 0 is no change. Horizontal line. That line never goes anywhere. Undefined is, first of all, the relation that you're looking at is not a function. But the second thing is we can't really talk about measuring that because it would, if you look at it, there is no change in x, right? It's just sitting at one place on the x-axis. Looking at our formula, that would mean we were dividing by nothing. Divide by 0, which is not allowed. That operation is not defined, so that's why we say that slope is undefined. The first way that we can find slope is based on a graph. So if we have a graph, what you should first do is identify 2 points that you know exactly what they are. Not things in the middle of a space that you have to guess, but things that you can say exactly, I know what this is. So for this one, this would be the point 0, 1. And this would be the point -2, 1, 2, 3, 4. So we are going to find the slope between -2, 4 and 0, 1. Now I'm going to show you a way to do this using just the graph. Some of you may already know the formula, and we'll actually talk about that in the next example. So I have to think how to get from point A to point B. And again, it's most effective if you think about this in terms of left to right. Okay, so we have our rate of change, which is our slope, and we use the variable m for slope, and that will equal our change in y over our change in x. So we have to decide how much we went up and how much we went over. I'm actually going to use the same colors from before. So change in y would be blue. So to go from A to B, I have to go up. 1, 2, 3, 4, 5. I'm just counting the spaces. So my change in y is 5. I'm going to change this color. So change in x is red. I'm still not at point B. I know I'm right next to it, but I'm not at it. So I have to go over to the right. 1, 2. My change in x is 2. So to go from one point to the other, it's simply how far did you go up and how far did you go over. That's positive. If you were going to be going down, if you were going to a negative slope, then that 5 would have been negative. Okay? Now, I do want to say very quickly that the way that I show this, if we're reading that graph from left to right, we should never go over to the left. Our denominator here, our change in x, should never be negative. It should always be a positive value. Okay? So, that's when you're using a graph, by the way. Now, let's take a look at what happens if you have a pair of points. Okay? I'm going to give you a formula. So we still have that the slope, I'm just going to use slope instead of rate of change. We still know that the slope equals still the same change in y over the same change in x. We need a formula. M equals. To find change, we need to find the difference, right? So we would subtract. And we say it this way, y2 minus y1, and the same for x, x2 minus x1. Now, what does this mean? Okay. Whenever you see variables in math with subscripts, so the little number at the bottom, it's not an exponent. Okay? The reason that we use that is we are saying we are having two things, x and y. x1, y1 is the first one. x2, y2 is the second one. Okay, so those little subscripts tell you which pair you're talking about. If there was a third pair, you could say x3, y3. Most people will say that the first ordered pair that you are given, if you're given 2 points, is x1, y1, and that the second one is x2, y2. You can change these around if you like. I highly suggest as you're getting started with this that you do label the ordered pairs just so that you remember. Okay, remember it's x comma y also. Now I'm going to subtract. I'm going to use the formula. When I do this, now the labeling will help. Writing the formula down will help. But I should remember two things. First, I can only subtract y from y. So if I put the 18 there, I have to put the negative 2 here. You should never subtract x from y or y from x. The second thing is they have to be vertically aligned, meaning the two parts of the ordered pair need to be one above the other. So if I put 18 here, the 5 has to go below it. And then the other 5 has to go below the negative 2. Okay? Now I'm going to do the subtraction. So 18 minus negative 2 is 18 plus 2, which is 20. 5 minus 5 cancels. That's 0. Okay? So this is an example of what I mentioned earlier. This one is doing something that you should not be doing. We cannot divide by 0. So this is undefined. Because that operation, 20 divided by 0, is undefined, the slope of that line is also undefined. This is a vertical line. And if you want to visualize it on the coordinate plane, it's a vertical line sitting right at x equals 5. Right? Okay, go ahead and do this one. I promise it's not undefined. So hit pause and then hit play when you've got your answer. The answer here is the slope is m equals 11 over negative 3, negative 11 over 3, however you want to say that or write that. So once again, I took my first ordered pair as x1, y1, and the second is x2, y2. Notice the highlighting I used there is that you can track then in my problem then, where you would see that I have the pieces of those ordered pairs vertically aligned, one on top of the other, y over x. And then I put them, right, y minus the other y, x minus the other x. 20 minus negative 2 is 20 plus 2, 22. Negative 20 minus negative 14 is negative 20 plus 14, negative 6. You do need to reduce. So it is 11 over negative 3. Now, can you use a decimal? Yes, but you shouldn't. When you get to the point where you are graphing linear equations using the slope, you're going to want that fraction. It's a lot easier to do it change in y over change in x versus, a slope of 1.5 or something like that. Okay? The last thing we want to look at is what happens if I don't know one of the coordinates. So in this case, I know the ordered pair 3, 1, the ordered pair 8, y, so I'm missing the y coordinate, but I do know the slope. I'm going to use the formula m equals y2 minus y1 over x2 minus x1. And then I'm going to plug in the different pieces. So y, and then I'm going to have minus, and then I'm going to have 1. And then on the denominator, I'm going to have 8 minus, and then I'm going to have 3. And that is going to be equal to 9 over 5. And you can decide where you want that negative to go. I'm going to put it on the 9, and the only reason I'm doing that is because I know 8 minus 3 is positive 5, so that just keeps that being a true statement. Otherwise, it just gets a little messy. Okay, so you got a choice. I know a lot of students that will solve this by proportion, so I'll show that way just because I think, like I said, that's a common way that I've seen. So in the numerator, we're going to leave that y minus 1. And then in the denominator, we're going to have our 5. And then equals the negative 9/5. So cross multiply. So 5 times negative 9 is negative 45 equals 5 times y minus 1. That's a distributive property. So we would get 5y minus 5. And then solve. So we would add 5 to each side. So I would get negative 40 equals 5y. Divide both sides by 5, and I get y equals negative 8. And just to check, negative 8 minus 1 is negative 9, which is what I needed, because I already know that 8 minus 3 is 5. Okay? All right. Hit pause, find that missing x, and we'll go over it together when you're done. And the missing coordinate is x equals negative 3. So do it the same way that we did before, except for x2 is now the missing value. So simplify and cross multiply. I get 2x plus 18, since the denominator on the right becomes x plus 9, equals 12, since the numerator on the right becomes 4. Subtract 18 from each side, I get 2x equals negative 6. Divide both sides by 2, and x is negative 3. Plug it back in to check. I get 4 over 6, which is 2/3, which is what I was looking for. All right, thanks for watching the video on slope.